Alright, let's move on from what we've been doing till now. We have mastered most of the skill we need to understand Pert. Pert is very similar to what we've been doing till now, sometimes what they call CPM, critical path method. Pert has become more popular lately, mostly as project management is very widely used in information systems or in the field of IT. What the biggest difference between Pert and what we've been doing, CPM, is instead of just coding one time for each activity. So earlier what happened is activity time, we had one code for the time. Say it will be done in 3 weeks. You can do it in a week if you want, but it costs more money. But now what people do is people code in Pert. It allows for variability. What that means is people code 3 times. What these 3 columns mean is in a best case scenario, it will be finished in 2 weeks. Most probable, it will be finished in 3. In a worst case scenario, it will be done in 4. So for each activity, there are 3 quotes of times. An optimistic, we call it A. Most probable, we call it M. Pessimistic, we call it B. So what we do is we find an expected value M, for each activity. The formula we use for that is expected time is A plus 4M plus B divided by 6. Basically, you use 1 part of your optimistic view, 4 part of your most likely, and 1 part of the pessimistic view. So in our case, it would be, so for A, it would be A plus 4M plus B divided by 6. So for A, it would be 2 plus 3 times 4 is 12 plus 4 divided by 6 comes out to be 3. Let's do a slightly difficult one. The B one is slightly difficult. 3 plus 4 times 4 is 16 plus 11 divided by 6. This comes out to be 5. So most probable is not always the expected time. That's what you should keep in mind. Now remember, this is just probability, right? There is some chance it will be 2, some chance it will be 3, some chance it will be 4, and by our formula of AM plus 4B plus 6, our expected time is 3. Given that there is some chance it will be 2, 3, or 4, we need to know what is the standard deviation, or what is some measure of variance, some measure of variability. The variance in this kind of method, where this kind of data, where you have a optimistic estimate, a pessimistic estimate, and a more probable estimate, the variance is given by a formula B minus A square divided by 36. Now you might wonder, why do we have these weird formulas for expected value or the mean and this weird formula for variance? The complete reason is kind of outside the scope of this class, but I'll give you the basic reason. What happened is researchers found that when we quote optimistic, pessimistic, and the most probable value, this kind of coding is very similar to, it follows a better distribution. So this kind of coding of optimistic view, pessimistic view, and a most probable, it is very similar to better distribution. Better distribution is just like normal distribution, except it has a fat tail here. In better distribution, the mean or the expected value is given by A plus 4M plus B, or 1 part of optimistic, 4 parts of most probable, and 1 part of the pessimistic view divided by 6. Obviously, the variance is given by B minus A square, that is this minus this end minus this end square, divided by 36. So that is the reason we assume So people have found that when we have to quote optimistic, pessimistic, and most likely view, our estimates follow a better distribution. That's the assumption. Well, after that, after you've calculated this expected value for all your activities, our problems becomes exactly same as what we have been doing till now. You make the project network using this expected time. Again, never use either of these activities, either of these times to make your project network. People usually don't use this or this. Sometimes I've seen people use most probable, because sometimes most probable value is similar to the expected time. Not always. So always make sure you use the expected time, okay, to make your project network. After we have done that, after we have found the critical, we do the forward pass and we do the backward pass and we find the critical path, okay, that's when the real use of Pert comes into play. Remember, Pert has that standard deviation built into it, right? Pert has that standard that variance built into it, and variance is very closely related to standard deviation. Now the next question that is, well, it's the same example. You can go ahead and do it, and the critical path you will get is B, C, E, F, H, J, K. Again, the project completion time is 22. It's the same example that we did before. Now the question is, how long? Remember, this is probability distribution, right? This 22 now in Pert just means that your expected time of completion of the project is 22 days. In our CPM method or earlier, when we said the project completion was 22, that was set in stone. We'd finish the project in 22 days. Now, because this probability built into it each activity, when we say the project completion is 22 days, we are just saying it is expected, or the mean is 22. Then I could ask the obvious question is, I could ask, say, choose a number, 25, say. What is the probability that the project will be completed before 25 days? What is the probability that it will be finished by 25 days? Well, there is something missing here. To answer that question, we don't know what is the standard deviation of this. The mean is 22. We don't know what the standard deviation of this distribution is. Remember from our first chapter, to describe a normal distribution, and we assume this to be normal, and that's the easiest way to do it, because better distribution is very close to normal distribution anyway. We don't have the standard deviation. We have the standard deviation of the activity for the processing time for each activity, but we don't have the standard deviation for the completion of this project, right? Associated with this 22, we don't have the standard deviation. Actually, it's a really hard problem to find the standard deviation of the project completion time. There are many ways people do this. People look at each path and all these things. In our class, we'll do the simplest of it, and it is pretty powerful and it's pretty correct. Remember, and the logic is this: to find the project completion, we looked at the critical path, right? You can add the expected time for each of this, and you will get 22. Adding the average completion time of each activity of the critical path gives you the project completion time. So why not use the same logic to get the standard deviation? Standard deviation has a variance, but because it is a root measure, you cannot add them. Whereas variance, you can add them all up. So to find the variance of this project completion, you can add the variance of every activity in that critical path, B, C, E, F, H, J, and K, and get the variance of this project completion time, right? You have the variance of the project completion time, which is 2.77, okay? After that, it's a pretty simple process, right? You have the variance. You can take the square root of variance. You can take the square root of variance, and you get 1.81 as your standard deviation. Okay. Now we have already done this in our first chapter. Your mean is 22. your standard deviation is 1.81, and I'm asking you what is the probability of finding a value less than 25, right? That's what it sums up to. Well, you know from our previous chapter, well, it's easy to do. All you have to do is assume there is another normal distribution, standard normal, where the mean is 0 and the standard deviation is 1. You have to find the equivalent of this, right? And you can go ahead and do this. Sorry, the standard deviation is not 1.81, is 1.66. So standard deviation is 1.66. So to find the equivalent, it comes out to be 1.81, and you find what percentage of the value is left of 1.81. Using the formula wise, remember the formula for G is x minus mu divided by standard deviation. X you are concerned about is 25. The mu of the normal distribution you are looking at is 22 divided by the standard deviation of 1.66 comes out to be 1.81. You look at the table, the corresponding value of Z is 9.9649, which means 96.49% probability that you'll finish the project before 25 days.